Hi guys, welcome back to Sapima tutorial. Today we want to be looking at sine rule, derivation of sine rule. We have a over sine A equal to b over sine b equal to c over sine c, or we say sine A over A, sine b over b, and sine c over c. We use this most times when we are looking for the sides of a triangle, and we use this mostly when we are looking for the angles of the triangle. But either of them can still work for either the angle or the sides. All right, so we want to look at the derivation of these theorems or this rule from these triangles. Now take note that we make use of sine rule or cosine rule, which we'll be looking at in the next video, when we have a complete triangle and we are asked to provide solution to the problem. But if you have a right angled triangle, we make use of trigonometric identities, that's SOHCAHTOA or Pythagoras theorem, h square equal to a square plus o square. All right, so but today we are looking at a complete diagram which we use sine rule or cosine rule to resolve, but we'll start with sine rule. Now to prove this, we have a triangle given to us, either acute or obtuse. This is acute because all the angles inside here are less than 90 degrees, and this is obtuse because one of the angles here is bigger than 90 degrees. If you look at it very well, you see that this one is flapping down. Okay, so this is bigger than 90 degrees. That's why we call it obtuse angle triangle. So we'll be looking at the derivation of this rule using the two triangles. So the first thing we do is to make our construction. So construct. What do we construct? The height of this triangle. Okay, so the height will be here. We call it h. For this one, to get the height, I'll draw it down from here. Right, we call it h. This a is for here. Okay, so the next thing we do, let me split the diagram into two. I'll be having this right angle. I'll also be having this right angle. So here remains my c, and here remains my c, the top. Here is a, here remains b, here is my h, here is h, here is a, here is still c, and here is still c. Okay, so we have replaced back the variables we have on the diagram. Okay, from here now, since we are proving sine rule, let's consider the angle here and the angle here, these two angles. Now let's make use of trigonometric identity to resolve this diagram. Trigonometric identity of sine says sine angle, sine of the angle here is equal to opposite. Here is the opposite of the angle, h, over the hypotenuse, which is b. Okay, sine theta says opposite over hypotenuse. All right, then come to the second diagram. I will have sine, this is b, I will have sine b to be equal to h over, this is the hypotenuse, h is the opposite, here is the hypotenuse, h over a. Then we cross multiply at this point. H times 1 is h equal to b times, here I will have b sine a. Then at this point, this one, h will multiply 1 as well. I will have h a sine b. Okay, now h equal to this, h equal to this. If this guy and this guy are equal, and this guy and this guy are equal, that means this and this are also equal. So equate the both of them. I'll have b sine a to be equal to a sine b. We can easily represent them as a ratio. A will be the numerator of this one, b will be the numerator of this one. But there is a way to derive it actually. Let's derive it. Divide both sides by sine a. Sine a will cancel sine a. I'll have b, okay, both sides. I'll have b to be equal to a sine b over sine a. Then we also divide both sides by sine b. To divide by sine b, since sine b is a numerator, that means we'll multiply by 1 over sine b. Multiply both sides. That is 1 over sine b. We are multiplying the two sides of the equation. So b times 1 will give me b over sine b equal to, b will cancel b here. I will have a over sine a. We have been able to prove that b over sine b is equal to a over sine a. Alright, so we solved 2 at a go. 3 of them are in ratios, but we solved 2 at a go. We either solve a and b, or we solve a and c, or we solve for b and c at a time. If I want to solve for c, maybe a and c, instead of producing the height here, I'll produce the height from here, from b to this place. Then I'll now solve for a and c. If I want to solve for c and b, that means I'll produce the height from here to here. So we have been able to show that b over sine b is equal to a over sine a, which in turn c sine c. Okay, so we have been able to prove that. We are going to be considering the obtuse angled triangle also. We have just considered the acute angled triangle. Let's use the obtuse angled triangle and solve. Remember, this is obtuse because one angle inside this triangle is bigger than 90 degrees, and we have produced the height at this point. So here is my h. Okay, now consider the triangle a, let's call here m, AMC. This big one, let's draw it out. Okay, here is my c, the top is my c, here is my a, let's call here m, here remains b, and then here is my h, this part. Okay, so since here is capital C, here will be small letter c. Then consider this triangle now, this one, that is BMC. Draw it out also. This is B, M, and C. Whereas here is my A, here remains my H. Okay, then there is an angle here, which is here. There's an angle here. Okay, you can call it whatever, theta. All right. So let's consider these two diagrams and solve the same thing we solved here. The only difference between here and here is that the height can be produced inside here, but the height is produced outside here. Then we're performing some operation here also because we have a total of 180 degrees at this point. So let's solve from this. Considering the angle A, I will have sine A to be equal to opposite over hypotenuse, which is B. I will also have from there, I will have sine, here is B, but I will not be using B because the angle from the original diagram, recall the original diagram was like this. The original diagram was like this. So here is the angle B. When I did my production, here will now become 180 minus B. This is the original angle given in the diagram. So 180 minus B, in the sense that to get the angle on this side, we have to remove the one that I have here. Consider this straight line and this line now. If here is 110, to get the angle at this side, I will say 180 minus 110. So to get the angle at this point, I will say I will have sine 180 minus B, which is the original angle given to us, which is equal to my opposite H over the hypotenuse A. At this point, we do the same process we took to solve the other one. H multiply 1 will give me H. B multiply here will have B sine A. And then H will multiply denominator here 1. I'll have H to be equal to A times here will have A sine 180 minus B. But we can remove this 180 minus B. Remember, we are looking for the angle here. If 180 subtracts B, which is the angle here, we'll obtain the angle at this point. But in the second diagram, we also have here as B. So we can replace 180 minus b with b. Therefore, I'll have h equal to b sine a and h equal to a sine b. The angle here is still b because we're looking for that angle there. So I have h and h, therefore equate the both of them. B sine a and is equal to a sine b. At this point, represent them in their ratios. A will come here. I'll have a over sine a equal to b over sine b. So whether I'm using obtuse angle triangle or acute angle triangle, we are arriving at the same point. So in my next video, I'll be solving examples involving sine rule. Thank you for coming on board. Please don't forget to subscribe to my page, like my videos, and share my content to your friends. Thanks a lot.